More and more children are out of school, but parents don't want math learning to stop. They're turning to Mathnasium at Home. Real-time math instruction tailored to your child's exact educational needs. It's the same face-to-face live instruction used in our centers for over 15 years, now on a computer. Your child can keep their math skills sharp, catch up, or soar ahead, from home or anywhere with an internet connection. To learn if Mathnasium at Home is right for your child, visit mathnasium.com/at-home. Mathnasium at Home, changing lives through math.
Hi everyone, and welcome back to Mathnasium Schoolhouse. My name is Sandra and I will be your instructor for today. And of course today we are revisiting our topic on math and art and seeing how math shows up beyond math. It actually shows up in different areas, and in this case we're exploring art. This is our part 3, so if you're interested after this, go ahead and revisit the lessons linking back to part 1 and part 2 of our math and art series. A lot of cool stuff there to follow along on to make your art pieces using math at the end of the day. So today my focus I wanted it to be on something that we do actually learn in the math classroom, which is proportions. We're going to do some math first and see then how that applies in a drawing that we can create using a certain method. And the really cool thing that we'll find out is artists actually use a lot of math in their drawings, specifically to make sure that when they have something big and they want to kind of shrink it down to the sheet of paper that they're working on, they have the proper proportions in place. And then we'll explore a little bit about perspective involved in all of that. So hopefully you're excited just as much as I am. I'm hoping that after all of this, whether you take away the math, the art, whatever it is, I want you to be able to tell yourself, you know what, I can be an artist. Just as much as I can be a mathematician, I can be an artist. All right? So let's carry on today. I'm going to show you my whiteboard. That's where we'll be doing our math. And we're going to start off by talking about, before we get into proportion itself, talking about when we're drawing proportionally, there are certain things we have to understand, and we're going to review that together. So the first thing we really have to understand is scale. All right, so I'm going to write that word down, and maybe you can tell me what you believe or what you understand scale to be. Okay, hi to those of you that I have seen before or that are new. Welcome, welcome. Glad to see you joining us today. Hopefully you're here because the topic interests you or just because math interests you, which is even better. So like I said, today we'll be exploring proportion, scale, and I'm curious to see what you understand about this term. You definitely would have heard about it in your math classroom. Maybe you can give me an example of what you believe scale is. Okay. But the reason we're exploring it, and we'll do a lot of examples together in just a second, is it shows us it tells us what that direct proportion of figures is. So when I give you the example of an artist with wanting to draw a little drawing of a big space, they need to understand the scale, the proportion that they're working with. And more specifically, we're going to be looking at scale factors today. Ooh, I like the example that I just read. I see someone said a scale is a ruler. Very, very nice. Yeah, you can absolutely use a ruler for scale. So I'll show you my ruler here, my Mathnasium ruler, which I'll be using later on in the lesson today. And a very, very funny comment just now. My mom doesn't like this scale at home. That is very funny. Very nice. Yeah, a scale can also tell us measure. You're right. There's something that we can find at home called a scale, which can also tell us how much something weighs. Very good. So we can see that it involves some measurement in place. And as I said, that the comment popped up. Very good. And as I said, we're going to be looking at scale factor, which means that we have to look at something called ratio. Let me know if you've heard of that term before. Okay. But when we observe the scale factor between two images, two things, we'll see examples of what those two things could be in real life. We're really looking at the ratio that shows us that relationship. A ratio is always showing us a relationship between a drawing or a model And then that real object, right? That real object, that real distance, if you think about a map. Okay, so we're going to be looking at the ratio and forming it in a few examples. Okay, and maybe some of you might have seen ratio appearing like this. So you might have a number here. I'll just use a letter. Then you have these two dots appearing, and then another number. But again, it's way better seen in examples, so we'll explore that right now. You heard about a ratio, very good. So maybe this will kind of help you remember what it is. So let's look at that. I'll leave the term up there, and I'll use my blue marker to give you an example. We'll do this one together, and then I'll give you some to work on your own. So let's say that I have a toy cat, okay? And I take out my measuring tape or my ruler, and I measure it, and I'm going to use centimeters just because I see it on my ruler. It is 16 centimeters long, okay? I measure this toy cat, the length is 16 centimeters, okay? But then I also have a real life cat, so I'll just say real cat, that this toy cat was built based on. And it has a length of 64 centimeters, okay? So I want to determine what is the scale factor here, okay? For those of you going into grade 5, grade 6, this is perfectly appropriate for you. So maybe you can especially help me out here. What is the scale factor here? Okay. So if I want to form that scale factor, I'm going to just write over here. Let's look at this as a fraction for now. It'll be a little bit easier for us. So we're going to look at the measurement of the model. So I can't really squeeze that in. Well, maybe I can. So let's even say, I'll maybe use a short form here. Instead of writing the word measurement, I'll just say measure of the model. In this case, that model is the toy cat, right? This toy cat is modeled after our real cat. So that's our model. That'll be in the numerator of our fraction that we form of our ratio, represented in fraction form. And in the denominator, which is just the bottom part of this fraction, I will have the measurement, all right, of the real life object. And in this case, I'm just using a lot of short forms here, so hopefully you're paying attention to my wording. A lot of you guys are already telling me the answer. I love it. So again, scale factor between this toy cat and this real cat means we look at the ratio between the two measurements, the model and the real cat in this case, right? We're going to represent it in fraction form, and then we can write it in ratio form, which you guys are already doing for me, which is beautiful. So let's see what this looks like in fraction form. Well, I know that the measurement of the model is right here. It's 16 centimeters. And the measurement of my real cat is 64 centimeters. And of course, as you guys are already showing me, we're going to reduce this fraction. And it looks like you guys divided out by 16. So if you need a review of reducing fractions, make sure that you revisit that before attempting these. But if we just divide 16 by 16 and 64 by 16, we do in fact get 1/4, as all of you are sharing with me. All right, so if we reduce that fraction, we do get that. So what does this tell us? What can we now interpret? What can we say we've learned about this scale factor? Well, one thing that we can say is that the toy cat length, which is 16 centimeters, is, well, 1/4 of the length of my real cat, which was 64 centimeters. So that's one thing I can say. Or alternatively, I can reword it by saying that my real cat, its length is 4 times the length of my toy cat, my model that I have. Okay, so 2 different ways. All in all, that shows me that my scale factor is 1/4. All right, looks like you guys got that beautifully. Very nice. Okay, and you guys are also showing me the ratio in ratio form, as you might have seen it in the classroom, which is beautiful as well. So you can represent it in fraction form or the standard ratio form that we're used to seeing. So before I go on to our next example, let me just pull out, I just found these in my room, in my office. So let's see, this is exactly what you're doing. So I don't have a toy cat or a real cat to show you, but let's see it as cubes. So let's pretend this is a perfect cube. This of course is as well. So one thing that I'm doing here with the scale factor is seeing, let's pretend again this is a perfect cube. Let's say I look at the height. What is the height of this cube? And how much does it have to grow by, right? What is that scale factor to get to be this one, this big cube? Okay, so we'll look at examples on how to do that. And some of you are asking, how do you get 16? I was given 16. I measured my toy cat and my measurement was 16 centimeters. So let's go on to another example. Let me remove this. I'll keep the top portion here, just at least for the next example. So I will ask you this time, let's say I have a toy tractor or a toy car, whatever you want it to be. It doesn't matter right now. And let's use another crazy unit of measure, let's say decimeters, but at this point it doesn't matter, right? We're caring mostly about the number here, but we need to know what unit we're working with. It's just an example, exactly. And let's say that the real tractor, oh, I apologize. This should be 9. I apologize for that. The real tractor, let me call it real just to keep it in line with my previous example, is 45. I'll give you a few seconds to help me out with this. What is the scale factor here? Still working with really nice numbers here, and hopefully some of you can see that really quickly. 9 and 45 work beautifully together. Why is that? Why are those nice numbers to work with? Right, so if I wanted to form the scale factor, I see it appearing. Thank you very much. Let me use my green for the fraction if that's what we wanted. I would in fact get 1/5, and that is because I would have 9 decimeters over 45 decimeters. If I reduce those, which is what I was saying earlier, they're nice numbers to work with because 9 divides evenly into 45, and that is 5 times. Okay, so that's our scale factor in fraction form, and if I wanted to write that out in ratio form, as you guys are sharing with me, I could say that. Yes, 9 times 5, it's 45. Hi, PJ. Nice to see you here. Okay, let's look at another example. These were nice numbers to work with, but of course, as with anything in life, numbers aren't always nice to us. So let's see, maybe we can work with some decimals. So if you need to pull out a scrap sheet of paper to compute some of these numbers, I completely understand. Let's say I have a copy of a painting. I'm just going to call it painting. Oh, sorry, copy. This is the copy. And it is 1.9, or in other words, the best way to reword this is 1 9/10, okay, inches high. All right. And it is 1.5 inches wide. That's the copy of the painting, right? So it's not the real life painting. Let's just say it's some small little replica I have of it. The original, on the other hand, is 36 1/10 inches high. And it is 28 5/10 inches wide. What is the scale factor between these two? So you're given 2 measurements. Interested to see what you use with those measurements. Give you a minute maybe to try that out, or at least think about it, and let me know what you're thinking. What do we think? So as I pointed out, not the nicest numbers to work with, just by looking at them. They don't look too friendly. Oh, I apologize if my one looks like you're saying it looks like a slash. Okay. I apologize. Maybe that's a good reason why I read them out or repeat them. So what are we thinking? So if I'm looking for the scale factor between, or the relationship, I can also say between this copy of the painting and the original painting, do I have to use both measurements? Maybe not. If this was a perfect copy of the original, the proportion between the height and the width should remain the same. If the artist or whoever did this did a good job, I should say, right? If they kept the proportion. Or else, think about it. If I wanted to take a picture of my face and I didn't keep the same proportion, I wouldn't look the same, right? Maybe I would have a longer face, a wider nose, who knows what. But if you don't keep the proportion the same, you don't have the same painting, right? So if this is a perfect copy of it, we're assuming the proportions are all there. Okay, so I'm going to just remove the width information here. I don't really care about it right now. I'm just going to stick with one measurement. I'm going to stick with the measurement of the height, just because, okay? So what I would do here is just like before, when I'm looking at my scale factor, let's create that ratio. Let's see what that looks like, right? So the scale factor of the height, that's what I'm looking at here. We're going to take the measurement of the model. In this case, it's the measurement of the copy of this painting. Okay, very nice. So I have 1 9/10 inches over the measurement of the real life object, or in this case, the original painting, which is 36 1/10 inches. Hi. And then this is where you would have needed your scrap piece of paper. Hopefully you're not tempted to use your calculator and you want to perform that division. I can understand the temptation though, and so I'll help you out here. If you in fact divide out 1 9/10 by itself, you get 1. That's our ideal situation. And if you do the same thing to the denominator, you get 19. So this actually gives you a nice fraction here with whole numbers in the numerator and denominator. Very good. Thank you for sharing. Okay. It is harder. Yeah, you're having decimals here. So it at least looks harder, but the idea is still the same. So you have 1 over 19. I just reduced this fraction here. Okay. And so what does that mean? What does that mean in terms of the copy of this painting and the real painting itself? I'll just write up the ratio here. How can we interpret this information? One way to interpret it is to say, well, 1 inch on my copy represents, in fact, 19 inches on the original painting. So can you imagine this really, really large painting and then this really, really small copy where 19 inches on that really big copy, that really big painting, is reduced to just 1 inch on this copy of the painting. Okay? So that's a more real life situation where artists use this information a lot when they want to replicate what they're seeing out in the real world or on a painting, but they have to replicate it on a smaller sheet of paper. So they have to work with some sort of scale factor. Okay? Let's look at a few more before we dive into some art ourselves. So let me remove this. I'm going to give you a drawing of a rectangle here. Okay, so let's say, and we're not going to care about measurements just right now. Let's say this is my original, and it has measurements of 8 and 10 here. And then I have the copy itself here, and I have 16 and 20. What can I say about the scale factor here? So I'm going to call this the original, and this is the copy. And again, think about paintings. This is the original painting. It was actually smaller, it looks like, than the copy that the artist replicated. So how can I find the scale factor here? Think back to the previous example that we worked through. So we don't need to use both measurements here. We can just stick with one. So let's say we want to stick with the width again. Why not? Or last time we did the height. So let's do the width this time. So we have 8 units, whatever it is that the artist used, and 16 units. So if I want to write that out as even a ratio now, remember that we need to have our copy first, or our model, and then our original. So in this case, I'm going to have 16 being compared. Yes, there you go. I'm seeing the answer up here now. Right? So we have the relationship between 16 units and 8 units. We can reduce that if you've worked with reducing ratios before. I know that 8 divides evenly into 16 twice. So there we go. There is my ratio, and some of you have already worded it beautifully. You said that the copy is doubled, which is exactly, the copy is twice as big as the original. Perfect. Very good. All right, which is exactly what this shows. So a real world example of this would be, so this is called something called upscaling, right? So we went from something smaller and we blew it up to something bigger. And so an example would be, I have a picture, my friend sketched me out a beautiful flower or a landscape, and I want to recreate this as a mural on a brick wall with permission. And so to do that, I need to take the proportions used here, the scale, and apply it directly to this space that I have. And so you're upscaling. Alternatively, I can do something where I have an original is bigger and my copy is smaller. Right? So let's quickly see an example of that. So let's say my original has dimensions 8 by 10 and my copy is smaller, 4 by 5. What is the scale factor here? Okay. For those of you that have questions on the previous problems, I see a lot of my helpers helping out in the comments. Thank you so much. And feel free to always come back to this lesson afterwards, pause where needed, and see if you can follow along with the math. All right? Always available to you. So if I take this, if I look at the scale factor here, it looks like I'm actually doing the opposite as before. I'm scaling down. I went from the original, looking like it's bigger, than my copy. So I actually reduced the image size, right? So let's look at that. I have, again, let's look at the width. I can compare the 4 to the 8. Yep, and in this case, when I reduce that, I get what looks like to be the opposite of what I had in the previous problem. The original is twice as big as the copy, or in other terms, I can also say the copy is half the size of the original. The width is. Okay? And one great example of this, if you want to share what your thoughts are, one good example of this when it comes to artists, think about architecture, right? So let's say I'm looking, let's say I'm an architect, and I'm looking at a landscape in front of me, real world. It's huge, as anything in real world is. When it comes to a building or anything like that, let's say I'm looking at a beautiful building that I want to draw. My sheet of paper is a lot smaller, so I have to determine what the scale factor will be for me to take something that large and then copy it over and draw it to the best of my ability in my sketchbook. All right, so let's look at one more example. Beautiful. Let me erase this. Let me erase this as well. Let's see if we can do this without that help right now. So you can use scale in a proportion to find actual sizes, right? So the best example I can give you is, let's say we're thinking about a map, right? For those of you that maybe haven't used a physical map before, you might use it online, but there's still scale involved in every map that we use, right? And let's say that this map tells us that 1 inch is equal to 32 yards. All right. First of all, let's even try to understand what this means, right? Well, what it means is if I look at my map, let's say I have a map in front of me, whatever is on here I'm exploring. It's a small sheet of paper, and for every inch, let's say this is an inch, on my page, on the map in front of me, it actually represents 32 yards in real life. So if I go exploring, what happens, the hills and mountains and whatever is here, all the roads in this 1 inch space, that actually takes up 32 yards in the real world. So that's the scale that we're working with here. So keep that in mind. So let's say I give you an example. I'll use my blue marker here. Let's say that if I have I'm sorry. You guys want me to draw a proper one? I will do that for you. All right, so let's say that on my drawing, so on the map, I have a length of 3 3/4 inch. So that is the length, okay? How long is that in the real world? How can I find that? Using this scale here that I know of. How could I find that? Okay, and this is where we can use proportions. So for some of you, maybe this might be beyond what you've learned in the classroom, but no problem. You can follow along here with solving proportions. So one way to do this is, in fact, to solve our proportions. So we'll set one up here. So using this information that's provided to us as to how this map was actually created, using the real world space, I can say, my proper one, 1 inch over 32 yards. Remember the model over the real world is equal to, that same proportion should hold here. So is equal to the length on my map. So I can stick with fractions. I can change that into a decimal, whatever works best for you. All right, like a legend, perfect, beautiful word to use here. That's exactly right. And some amount in yards down in the denominator. And for some of you that maybe have explored variables already, maybe instead of a question mark, you will have seen this as, you'll have a variable here, let's say x. So there's some x amount of yards, and we have to solve for this x. So let's use the red one. So depending on how you would have already observed this, explored this in the classroom, you can solve it, you can cross multiply, or you can play around with numbers if you've never seen that yet, okay? And see, what do I need to do to the 3 7/75? What do I need to divide it by to get to the same amount? Whatever you choose to do, you end up getting that x is actually equal to 120 yards. So I'll let you discover that. And in one of our upcoming Schoolhouse lessons, we'll explore solving proportions in detail. All right? So to conclude this problem here, what did I learn? Well, if on my map I have a length which measures 3 3/4 inches, in real life, that represents 120 yards. So if I decide that I want to walk that distance, drive that distance, bike that distance, I need to be prepared to actually travel this much distance, all right? So keep that in mind the next time you are looking at, oh, great comment was made. Yes, you can turn 3 3/4 into an improper fraction and then multiply it. Love it. Very great answer. Yeah, whatever techniques you have in place to solve that, go ahead. If you don't have any, reach out to your nearest Mathnasium and I know they'll be happy to help you. So let's conclude by putting this all together and seeing how this applies in an art project that you can maybe follow along with at home. Okay? So putting it all together, we can do something called, participate in something called grid art. Okay, and this used to be one of my favorite things to do as a kid because what it means is, and I don't even have an example here, but what it means is I can take a small little drawing and make a bigger poster, or I can do the opposite. I can take a big poster and make a small little drawing. Really cool, right? And the way that we are going to do this is use a grid system. And the nice thing is that artists use this all the time. And so when they create this beautiful image, the fact is they're actually doing what we're going to be doing right now, right? But maybe they can do it a lot faster, right? Artists have their own talents in place. So what this is going to involve And again, you can follow along with me here. I'll fill in some of the steps that I've already done behind the scenes. But what it involves is drawing a grid on some photo. Choose your favorite photo, even a family photo, and you're going to get permission to use it, or you can print one off as I did here. I have Larry with us today. This is part of our Mathnasium deck of cards. So my intention here is to take this small image and make a way bigger one, okay? My printer, for some reason, didn't want to print me a bigger one, okay? But just remember, with the ratios that we worked with today, remember that if you ever want to go from a small drawing to a big drawing, you have to have equal ratios. So for example, if my photo, not this one, let's say my photo is 5 by 7 inches, okay? Width and height and width, doesn't matter. That means that when I blow it up, when I want to increase the size, I can use paper that is in proportion to it. If you have flexibility in the paper you use, you can use, well, 10 by 14. Why is that? Because 5 times 2 is 10, 7 times 2 is 14. I'm maintaining the same proportion. Likewise, I can jump to 15 times 21. 5 times 3 is 15, 7 times 3 is 21, and so on. Okay? So one thing that you might do is measure out a sheet of paper and cut it up to this size, if your photo starts off at this size. So use that little trick whenever you can. In my case, I didn't want to cut up my sheet of paper, so I did something slightly different. So I'll show you here really quickly before we end for today. I'll of course need my ruler, possibly my pen, but I've been using a pencil, and I tend to use a pencil when I'm not on camera so that I can erase. It's just the pencil might be difficult to see, so we'll see. Okay, so the first thing you're going to do is take your small image, all right, and you're going to make a decision, how many boxes do I want to use? So you can see here I used 3 along the width, 4 along the height. There are squares. When you get comfortable, you can make these into rectangles. Just when I mean comfortable with proportion and maintaining that. But squares are the easiest. And if you're not too confident in your drawing ability, you would want to use more boxes. So instead of me using this really big one here, I could decide to split it up into 4, and so split up all of these squares. All right? Yeah, I love this ruler too. It's my cool Mathnasium ruler. Okay, so remember that. If you're not too confident in your drawing, include more boxes. That's completely up to you. Okay? A lot of flexibility when it comes to art. Then you're going to determine your scale. Okay? So what I did here was I drew my outline of my image. This is what I wanted to kind of, I keep using the term blow up, but upscale, I should say, into my bigger sheet of paper. Okay, so I want it to be here, and I'll show you that in a second. And I determined I don't need too many boxes. I'm kind of confident in drawing these lines out. So 3 here, 4 here, and each of them measure. So I used my ruler to measure them to be 1 1/4 inch. Okay, 1 1/4 inch here, 1 1/4 inch here. All right, so that's what I did. And then when I finished drawing that out, it's time to label it if I really wanted to. So I could label this A, B, C, 1, 2, 3, 4. That's completely up to you. Okay, it kind of makes it a little bit easier to follow along. Then I have to draw my bigger grid. So I take out my bigger sheet of paper, okay? And what I did here, starting with my longest side, because I always want to make sure my long side fits onto my sheet of paper, is I know that this is 11 inches high, this sheet of paper. And I know that I have 4 squares here. So I took my 11 inches and I divided it by 4. And when I do that, I found out that the length or the height of these squares here should be 2 3/4 inches. So I took my ruler, and on this sheet of paper, using my inches side, I measured out, you can't see this here, but I promise it's right, 1 inch, 2 inches, and almost 3 inches, but not quite 3/4. And because it's a square, I know that the width has to be the same. So again, 2 3/4 width. Let me do that one more time here, and I'll show you how to draw maybe one square using this. So I'm measuring out 2 3/4 here, and I know that the height is correct. So there's my other square. I didn't draw a perfectly straight line. Pretend, please. So let's say that these are the two they are the two squares in the top part of my image. So this is cell C1, and this is cell B1, right? Column B, row 1, column C, row 1. So how I can kind of upscale this image here is to look at only the square in B1 and draw that here. So using proportion, I can see, for example, Larry's head in this box ends right in the corner, and it kind of hits the top 1/3 of the way down. So I'm going to kind of note that for myself here, and then really quickly, that's not the best curve. Not the best. I'm not happy with that. If I wasn't on camera, I'd erase that and try it all over again. But for the sake of time, I can also draw the top of Larry's hairline here in this little cartoon. And it looks like it reaches just at the half mark, maybe beyond it just the slightest bit. And then there's an A+ that I would carry on to draw almost halfway here. Knowing me, I'd be doing a lot more measurements. I'd really be looking at, okay, does this reach 1/3 of the way, half of the way? And the funny thing is, that's exactly what artists do too, right? They want to make sure that they're maintaining the exact proportions so that, as I said, Larry's head doesn't end up too long, too wide, the hair is at the center as it is in the image, and so on and so forth. So what you would do is carry on with this grid and end up with Larry, instead of being this tiny, he'll be so much bigger on your page here. Okay, you'd have 3 squares here and 4 squares here with some leftover white space here that you can cut off. Okay, so I'm going to leave you with that, and that'll be your only challenge for today in terms of some practice that you can carry on with. So I welcome you to come back to this lesson, and if you need this image, maybe we can make that available for you. Or choose your favorite. I think that's the best thing to do. Choose your favorite image and upscale it, and alternatively do the opposite. Find a larger image and create a smaller one of it. Okay, I'm going to end it off there, but keep in mind that this doesn't just apply to 2D objects, it also does apply to 3D figures, right? So I could also take this cube and draw a smaller version of it on my white space here. And the trick to doing that is to also use perspective. So let me just show you what I would do here. So I would determine some sort of horizon, some horizontal line. That's what the artists call the horizon, and some sort of vanishing point. And then let's say I wanted to draw this figure here. It's below the horizon, so I draw, let's even say like that, I draw a square here. And then you're going to take your ruler. For the sake of time, I will not. I'm going to trust my hands to guide me from every corner to this vanishing point. And then depending on how tall or short I want this cube to be, I draw parallel lines. And then, if you follow along with me here, I erase. This actually doesn't even look like it's a cube. It looks like it was a rectangular prism. That's all right. I'm going to just erase my green, and voila. I have a 3D representation of my rectangular prism. Okay? So really cool tricks that artists use on a daily basis. Feel free to use them and understand. I hope you can easily see there is math behind it all. I'm going to leave that with you guys. Hopefully you have fun carrying out some of these art activities on your own. We'll see you tomorrow. Have a beautiful day. Smile loads. Bye-bye.
It's afternoons that seem to be the most hectic for us, so it was much more convenient when we found Mathnasium at home.
All right, so how do we do half of 5? I think one of the best things about at home is that it really feels like you're almost at home with the student in their house teaching them.
I'm in my comfort zone.
You can just ask for help and the instructor will come right to you.
With Mathnasium at home, I know that they're getting the help that they need.
Awesome, great job.
Mathnasium, changing lives through math.